the IMF diagram questions. So say we had a situation where we had like H2O and CH3Cl. All right. So the first thing we need to do is draw the Lewis structure for each of those. Okay. And we know that this is bent, and we know that the oxygen pulls harder on the electrons. So oxygen in this case is going to be partially negative, and the hydrogens are going to be partially positive. Okay. Now let's draw the Lewis structure for this. We're going to get 4 bonds. Okay. Now, I told you guys in class that the CH bond is pretty much negligible, right? It's non-polar. There's no dipole there. If there was, there'd be a small dipole going towards the carbon. But in this case, the Cl does pull harder than the C. So even though it's tetrahedral, we do have a dipole right there where that's partially negative and that's partially positive. So when these things get near each other, and I'm just going to draw it right here, the partially positive on the water is going to be attracted to the partially negative on this molecule, and we are going to get a intermolecular force, which is going to be this dude right here, and that is going to be called a dipole, because that's a dipole, to a dipole, because that's a dipole. One sec, guys, I'm almost done with this. So a dipole to a dipole connection is what's going to happen there. So remember that the CH bonds are essentially nonpolar, and this intermolecular force, you can grab it, Serena, this intermolecular force is essentially a dipole to dipole force. So let's do another situation in which we had something like NaF with H2O. So in a situation like that, you have the Na plus and F minus ions, which are then going to form an ion dipole force with the H2O. So in this case, the negative side of the water molecules, okay, the polar water molecules, which have a set dipole, and I'll make that plus, are going to form an ion dipole interaction, because that is an ion. We have a total transfer of electrons, and that partial negative on the O, because those are shared electrons, is going to form right there. That is an ion in the sodium to the dipole on the water. Conversely, on this side, you can think of this fluoride as getting slapped by the water, by those hydrogens, whereas the Na is getting headbutted, if you will. But still, this is going to be another example of an ion in the F minus, an anion in that case, connecting to the partially negative on the water. Okay. Now, last thing, let's say we had something like CO2 with H2O. Now, if you had CO2, we know that CO2 is completely nonpolar. It does have a dipole on this side, and it does have a dipole on that side, but those dipoles cancel each other out, so we don't have to draw the partial charges. And we have water, partially negative, partially positive. I should have drawn that in red, my bad. There's really nothing causing the water molecule to be drawn towards the CO2 other than this random sort of movement of electrons. It just happens spontaneously where there's really no permanent dipole that exists. And rather than get into what that is, we're just going to call that a London dispersion force, and I want you to know that's the weakest of all the intermolecular forces. If we threw in this mix another something else, like let's say an iodine molecule, the iodine molecule is going to hang out with the CO2 simply by default, because all the other water molecules are aggregating together, having an actual real conversation, and these CO2 and I2 molecules are having this totally awkward, lame London dispersion conversation, which is essentially why nonpolar molecules tend to layer out on the top, because their weak intermolecular London dispersion forces limit their density in this situation. So it's important to remember that an intermolecular force is a force between. if you cannot draw molecular geometry, you're going to be completely hosed in this situation. It's the bent nature of the water which allows the dipole to exist. Those dipoles then are going to attract one another in a similar way that two magnets would attract. And an even stronger example of that would be when an ion from some ionic compound would be attracted to the dipole. All right, Cologne, what's up?